Well, now instead of looking at systems of equations, whether linear or nonlinear, we're going to look at systems of inequalities. For the most part, when you're dealing with an inequality, you're going to go ahead and do your graph like you normally would, but then you're going to have to shade on one side of your graph or on the other side. So let's go ahead and graph the solutions to this inequality. Well, for the most part, you want to go ahead and make yourself a t-chart, meaning an XY chart if it does not end up being something that you recognize easily. So you make yourself a t-chart, an XY chart. In this case, since we're dealing with more or less y squared minus 4 less than x, I would make my t-chart and choose values not for x like we normally do, but for y since we have y by itself. I mean x by itself, then choose values for y. When you do that and plot your points, you're going to get a smooth curve, parabolic curve like this going to the right. Now it's dotted because there's no equal to underneath. If it was less than or equal to or greater than or equal to, then it would have a solid edge. Well, after you do that, you want to go ahead and choose a point. Well, the point that I like to try is the origin because it's 0, 0, and that's easy to work with. The only time you cannot choose the origin is if the edge of your curve, the boundary line curve, goes through that point. If it does, then you got to choose some other point that's not on your curve. You then want to go ahead and plug that point of 0, 0 in. 0 less than 0 plus 4, is that a true statement? In this case, yes, it is a true statement. Since this point we plugged in and it works, we're going to shade on this side. If this point here did not work in our problem, then we would have been shading on the outside. Well, when you're dealing with a linear inequality, you're really going to have your line here, and it really cuts your coordinate plane into two halves, a blue half and a yellow half in this case. One of the halves will work for you, one of the halves won't work for you. So if this was an inequality, it is quite possible, depending upon your inequality equation or inequality you had, every point up here would work for you, and any point on the line would work for you. When you're dealing with a system of inequalities, though, you're going to have two inequalities. So you're going to start off with your pink one here, and the pink is everything up here, and then you have your blue one, which is everything underneath your blue line, which is everything down here. So you had two halves here from your pink. You had two halves here from your blue. When you do a half of a half, you get fourths. So it divides your coordinate plane into four parts. Here, this part only works for the pink. Here, nothing shaded, so it doesn't work for either one. Here, this part only works for the blue. Here, this part works where they both are, since they're both shaded, it works for both of them. So for the most part, we're only looking at where they have their shading in common. So that would just be the blue. So your final answer would be your lines here and then just shading where the blue is. Sometimes you can have more than just one inequality. So here we have this one. We have four inequalities here. Y greater than 0 means it's just going to be shaded above your x-axis. And this one here, we have x being greater than 0. That means we're shading to the right of your y-axis. In other words, when x and y are both positive, well, you know that's just the first quadrant. So for the most part, all you're going to do is you're going to go ahead and graph these two inequalities, and you're just going to put your graph in the first quadrant because these two down here say you have to be in the first quadrant. Now, the easiest way to graph these is I would go ahead and get y by itself. And while here I know my y-intercept is 4, My slope is negative 1, so I go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, and so on. And so I get this blue line. Looking at the next one here, I get a negative y is less than or equal to a negative 2x plus 4. That's a 4, by the way. And then remember, when you multiply or divide inequality by a negative, you got to switch your inequality sign. So now I know I'm going to have a y-intercept being negative 4, which I have here, and my slope is 2, so go up 2 over 1, up 2 over 1, up 2 over 1, and so on. On this one here, you know you're shading below because y is less than, so you shade below the blue. This one here, you know you're shading above the pink one because it says y is greater than. Well, in the first quadrant, below the blue, above the pink is only this shaded area here. Well, you can still have systems of inequalities even if they're not linear like the one above was. Here we have a circle. It's less than 16, so that means you're shading on the inside of your circle, and you could choose a point just to double check that. You should realize that this is a circle centered at the origin with a radius of 4, because remember this is r squared. Your center here is 0, 0. You go 4 units out each way and draw in your circle. Now, if you did try the origin here and tried it in here, 0 here plus 0 here is less than 16. It's a true statement, so you know you're shading on the inside of your circle. When you look at the next one here, once again, it's just an equation of a line. We go ahead and get y by itself. You know your y-intercept is 2. Your slope is negative 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, and so on. And you know you're going to be shading above that. So the first one says you got to shade inside the circle. The second one says you got to shade above your line. Where do they both have that in common? That's just the shaded area here. And that's what we're looking for. It's just where they overlap each other.